Alright, hi everyone. I hope you had a nice break. My name is Jordan Watts. I did my internship with Kingsford Charcoal in Summer Shade, Kentucky. I actually started a little later than the other interns. I started in the end of July, and I'll be continuing on until January 12th. And my manager is Brian Shuck in Summer Shade. So a little bit about me. I'm originally from Roanoke, Virginia. We are called the Star City, which is why I have this picture. We have a giant star on one of our mountains. It's a really fun place to go. I'm studying chemical engineering at Virginia Tech. I have a year and a half left, so I'm hoping to graduate May 2019. And some of my interests, I have a huge passion for working with kids, especially doing STEM education. A lot of kids don't like math and science, so I think it's really fun to blow their minds with really cool experiments. I love dogs. This is my dog right here. And I love the outdoors, climbing, camping, hiking. I love it all. Kentucky has not had a lot of mountains, so I'm excited to go home for Christmas and maybe hike a mountain. So the purpose of my internship was to get real world experience that I wasn't going to be able to get in school. And then also I wanted to be able to provide meaningful work to Summer Shade when I was there. And the product of my internship was that I learned a lot of new potential career ideas, and I gained a lot of experience. My boss sat down with me all the time and talked to me about ways that you can be successful as an engineer in the industry. And then I was also able to work on projects while I was there that will really improve the quality of our char, and we'll be able to have a more consistent product. So I'm really excited to talk to you guys about those projects today. So at Kingsford, I had a lot of opportunities to work on a lot of different projects. These are some of the highlights. I worked on a focused improvement team and a learning team, which these are just problem-solving methods in the industry, so those were really useful to learn about. And then I also got to take samples for a corporate research and development trial. I worked night shift for this, so that was a really good experience. And then I also got to work with Process Book a lot and update some of our screens. I got to learn how to make pie tags and add graphics, so those were really good because Process Book is used a lot across industry. But the main projects I want to talk to you guys about today are my dry wood moisture meter and my char moisture meter. And these meters, I hope that we'll be able to rip and reapply them to other plants because they were really successful at Summer Shade in improving our char quality. So I'm really excited to talk to you guys about those. So in order to explain my projects, if you've never been to a Kingsford plant or you don't know the process of charcoal, everything I'm going to say is probably going to be really confusing. So I'm just going to take a couple minutes to explain the process. So we start off with wood, and this wood goes into the dryer, and the purpose of that is we want to get rid of the moisture, but we don't want to get rid of it all the way because we don't want it to be a fire hazard or have an explosion hazard going through the process. And so when it goes into the furnace, we still want it to have a little bit of moisture. And so at Summer Shade, we have a 6-hearth furnace. A lot of plants have a 5-hearth furnace. And it's kind of hard to see, but this is a picture of a hearth in the Glen, Mississippi furnace. I got to travel there and see inside of some of their equipment. So I'm going to pass this around if you guys want to see it. And so in the furnace, we go through the first 2 hearths. Like I said, it's still wet coming in, so we want to evaporate off that water. That way we can go through in our last 4 hearths a chemical process called pyrolysis, where we're actually going to turn our wood into char. And so here's our char. Here's another wood sample. And so moisture is really important in this process because if our wood coming into the furnace is more wet than you anticipate, we're going to spend more time drying off this wood and less time in pyrolysis. And that's not good because char is one of the raw ingredients that goes into the briquettes. And so if it didn't go all the way to char, it's going to be more woody, and we're going to have to spend more money putting starch into these briquettes to hold them together. So that's not good. And then if it's less wet coming in, we're going to have more time in pyrolysis, and so we're actually going to overcook our char, and that's not good either because that's going to mess up our volatiles, like it was talked about earlier, and that's not good because our customers won't be as happy. So we don't want that either. And so it's really hard to understand things as an intern. You're only there for 6 months, and there's a really big process. There's a lot going on, and I was really confused a lot of the time. So this guy, Chad DeWeese, would always draw me pictures. He would give me analogies so that I could understand better. And so my favorite one is if you have 3 pieces of meat, you put 1 in the freezer, 1 in the fridge, and 1 on the counter. And then you take all of them and put them on the grill for the same amount of time. your piece of meat that was in the freezer is actually going to be undercooked. Your piece that was in the fridge is going to be just right, the perfect piece of meat, and the one that was on the counter is going to be overcooked. So what we want is we want that perfect cooked piece of meat, which is what we're trying to do with our char. And so our current method for understanding moisture is our operators will go and they'll take a sample about 3 times per shift, that's every 4 hours, and they'll put them on these CompuTracks and it'll get them a moisture reading. And then they make changes to the process based on this moisture reading they got. And like I said, they only do this every 4 hours. The changes that they're making is really slow and not updated. And then depending on the operators, it could be very variable. They could take samples differently, so that's not good. So our new method is this microwave moisture technology. It's this hydronics that can be installed right into the process. And it can take samples 25 times per second. So it's a lot faster, and our operators now have a way to have live information on how the moisture is changing and reacting. And it's also very reliable as long as you install it properly. That's a really big thing my boss taught me. You want to make sure your equipment's installed properly, and then if it's calibrated correctly, then it'll be very reliable. So in order to implement hydronics, I had to learn a lot about signal processing. That is not something I've ever learned in school. So everything I knew about it came from my manager and watching YouTube videos, and then a lot of trial and error. So as you can see from this top picture, it's very bouncy. It's kind of hard to read. This could be due to a lot of things, like the screw lights getting in the way with the signal. And so this bottom picture here is a lot more clear and concise. It flows better, smoother, and so you can really understand what your moisture is doing. And so next I had to go through a calibration process. And at first I started out doing a running method where I would take samples while we were actually running. And it was hard for me to do because you have to get a high moisture reading and a low moisture reading in order to get a good calibration. And it was hard to know when we were going to get spikes in moisture. And so I actually came up with a bucket method where I made my own moistures in 4 different buckets. And then on a down day, I was able to take the meter out and put it in the buckets and get my own calibration that way. And so the results of this meter were really awesome. The green line is our drywood moisture, and the blue line is the char weight coming out of the furnace. So as you can see, the green line is able to predict the blue line, which means that now we have a way where we can understand if the moisture will flatten out, we can understand how much char we're going to be able to make. And so this will be better for our consistency. We don't want to overwhelm the process if you have an upset and a lot of char coming out. And Summer Shade is actually doing a pavilion pilot right now where that's basically a high-level control, more complex PID loop, and that'll make it so that the pavilion will be able to control this and make it straight so that our operators won't actually have to make changes anymore. But this can still be a win without pavilion because our operators can see the live information. And then this is great because retort will no longer be our constraint. Currently, briquetting is always how much char are they going to be able to send over, but now it's can briquetting keep up with all the char we'll be able to make. And so this meter was very successful that my boss and I decided to change the whole route of my internship to installing more meters. And so the next one was a char moisture meter. And the goal for this one was to improve safety and then to also hopefully be able to predict volatiles and yield. And so this one was a lot easier for me. I already knew what I was doing. I was not going to make the same mistakes twice. And then I also didn't have to wait for a down day to calibrate this one because I could ask our operators to change the amount of water going to our char. So I could do it a lot quicker. And so the results of this meter, the blue one, again, is our char weight coming out of the furnace. And our green line is our char moisture coming out of the furnace. And so there's a very good inverse relationship here. And the weight coming out of the furnace, that's measured by using a char weigh belt, which is a very kind of fragile piece of equipment. It costs $250,000 to install, and the maintenance fees are $30,000. And so it was a pilot at Summer Shade, and it's a great way to understand how much char we're making. In a lot of places, you know how many bottles you're making, you know how many bags you're making, but with char, it's just going into our briquetting process, and so the weigh belt was a way for us to understand how much char we're making. But the meter is only a $10,000 install, and if there's a break with the screws or something and it breaks the meter, then we don't have to go through the whole installation process again, we just have to put in a meter. And so the biggest thing I learned from the calibrations was that getting a good sampling method is very vital to the good calibration, because you want to make sure that you're getting the right data. And then for future validation, you don't want to think that you're getting the right data, and you don't want to think your meter is wrong when it's really right, and you don't want to think it's right when it's really wrong. And so having a good sampling method to go forward is very key to this. And with this graph, this is our operator's measurement with compared to the moisture meter. And then this one is my measurements compared to the microwave meter. So you can see there's a really big difference, a lot of discrepancies between those two graphs. And this can be due to a lot of different things, like the operator is leaving out the samples longer and it dries up a little bit more, or they don't mix the sample as well, and so we're not getting as representative of a sample going onto our contracts. And so I also had a lot of help with statistical analysis to validate these meters. Mark Rasick, he was very helpful in this. I've never even met him in person. He just talked to me on Skype. So I think that's a really great aspect of Clorox. It's someone that hasn't met you, an intern at that, is they're willing to help you and teach you things that you're not going to learn in school. And so, like I said earlier, I have until January to finish up my internship. So when I go back, I'm going to be updating sampling procedures so that we have better information going forward, and so that we'll have a better win and other plans for the sampling for the meters. And then I'm going to come up with a PowerPoint deck for the hydronics meter and the calibration process, so that when I leave, my plant and the other plants will be able to install these properly. And then creating a PID loop to maintain our char moisture at 15%. 12% is where you kind of get into the fire hazards and scary zones. So we want to make sure our moisture is staying at 15% with our char. So that's what the PID loop will help with. And then during my time at Clorox, I was able to really relate with the calls to action. If not every week, then every couple weeks, and they really matched up with my internship takeaways. So putting the consumer first, this is actually my second internship, and throughout school I never learned about how the consumer is important in making these products. Every change that we make is going to affect the final briquette, so we want to make sure that we're thinking about the consumer with our changes to the process. And then theory in school can't always be applied in real life. Real life is a lot messier, and I had to learn that with changing to the bucket method and everything. So just embracing change and not being afraid to, if it's messing up, right away to change your method. And then ask a lot of questions. I probably asked a million questions. That's probably an understatement, because there's just so much going on in a plant. And so just making sure you communicate when you don't understand. There's nothing worse than someone asking you to do a project and you do the work for it and find out that they really wanted you to do something else. So making sure that you don't waste time that way. And don't be afraid to dig. That's something my boss told me weekly. He wanted me to remember that he didn't want me to think that everything that they were already doing at the plant was the best it could be or the best method. He wanted me to dig into things like the sampling methods, for example, and just find ways to improve the process. And then Jordan's meters. This is something that I heard all the time. Everyone would say, how are Jordan's meters doing? And of course they're not my meters, they're Clorox's meters. But I really felt a sense of ownership with these meters. I wanted them to be the best they could be. When I leave, that's going to be the legacy that I leave with that plant, and so I don't want them to have a hard time understanding the calibration procedures or anything. I want it to be a win at the plant and other plants. And so some of my highlights, I got to go to a couple different Kingsford plants, Burnside and Glen. That was very interesting for me because I didn't realize how different a plant that makes the same thing could be. So it was really cool to see that. And then I got to meet Dawn Willoughby and be a part of a presentation that we gave to her. So that was really nerve-wracking and exciting. And then my favorite thing that I did was I learned how to weld. That's not something I ever thought I would get to do. And it was really awesome. And so just a huge shout out. Summer Shade, if you guys are listening, I know you're all the way in Kentucky, but it's only been 2 days and I miss you guys already. That place is a huge family. They wanted me to succeed, and from day one, they were so great to me, and I moved there all by myself, so they really were my family. So, does anyone have any questions?